Kodak Video Programs proudly announces a brand new video series of animal programs for children of all ages. Titled Animals in Action, this 12-volume video series combines fun and fact as you meet animals of all sizes and all shapes up close. See how animals live and adapt to their world. Laugh at rare moments of animals at play. Learn all about the differences of animals, how they move, talk, see at night, build their homes. With beautiful photography by award-winning Survival Anglia Limited, Animals in Action is a series you'll want to collect and enjoy over and over again.
A remarkable variety of animals are specially adapted to life in trees, like this three-toed sloth. An eye in Madagascar even has a unique finger adaptation for tree living. There's a science fiction look about this African chameleon, still another tree dweller. And in Europe, an ichneumon fly may well exhibit the most extraordinary adaptation of all to the very specialized kind of life that exists high above the ground in the branches of trees.
Hello, I'm Thane Maynard, and welcome to Animals in Action. Most of us take trees pretty much for granted. They're nice to look at, and sometimes even fun to climb. But that's about it as far as we're concerned. But today, Keith Shackleton and I are going to take a closer look at trees, right?
And don't forget the animals that live in them.
And that includes some pretty remarkable types, as we'll see.
Trees offer a wide variety of advantages to certain species. They offer safety, they offer a ready food supply, and they offer shelter. Some animals have adapted so well to the high life that they are designed for little else. This is a three-toed sloth. It barely manages to drag itself along the ground using its claws, but those toes are much better equipped for a life in the trees. That's a two-toed sloth. Sloths are in no hurry. They actually sleep for 15 hours a day. Their food is close at hand, and few predators can reach them up there. You can see how those meat-hook claws come in handy for gripping branches. This sloth's hair is even wonderfully adapted for tree living. It's covered all over with a greenish algae to keep it well camouflaged among the branches. This eye, a relative of the lemurs of Madagascar, is a nocturnal tree dweller. You can tell that by its large eyes, suitable for night vision. Here on an island off the southeast coast of Africa, an eye is feeding on coconuts. It has a very long middle finger for poking into the fruit. It also uses that finger to scrape out grubs from within bamboo stems. The eye listens for the sound of grubs moving about inside with those large ears. Once it has located the grub, it bites the base of the bamboo stem with its sharp teeth and gnaws a hole in its side. Then it uses that thin finger to hook the grubs out. That's the sort of hole an aye-aye leaves after it's finished its meal. Madagascan folklore used to say that anyone who killed an aye-aye would die within a year. As a result, the aye-ayes were protected and safe. But now the aye-aye is nearly extinct because most of the bamboo forest have been cut down. Koalas, on the other hand, are keen on eucalyptus trees. They're a very specialized group of animals that live in these eucalyptus trees in Australia, and a very choosy lot as well. Out of the 350 species of eucalyptus that grow in Australia, the koala only eats 12 species. They're known to pack their cheek pouches with 2.5 pounds of leaves a day, like hamsters storing away available food. These animals have adapted themselves to the dry Australian regions where these trees grow. They actually get all the moisture they need from the eucalyptus leaves themselves. In fact, the name koala comes from the Aboriginal word meaning "I don't drink." Koalas have wonderful gripping hands. They have 3 fingers on one side with 2 opposing thumbs, all armed with sharp claws. Koalas are marsupials, mammals which give birth to their young at a very early stage of development. The rest of the development continues in the mother's pouch for 6 months. But when it's a bit older, the baby clings to its mother as she moves among the trees. This is a wonderful tree acrobat from the forests of East Africa. It's a colobus monkey, and look at that spectacular black and white coat. All that white hair acts like a parachute to break its fall when it leaps. And some of those descents are over 40 feet. They travel along familiar pathways through the trees, just as we use trails along the ground. But like so many other forest animals, colobus monkeys need a great deal of space. A family group of 8 will sleep in a couple of trees during the night and for most of the day. They spend the rest of the time feeding on acacia leaves. Colobus monkeys have a special stomach with pouches like a cow's, and this enables them to digest their leafy diet. When they're not eating or swinging, they're grooming themselves and looking after their young. Like most monkeys, colobus monkeys are essentially family animals. Here's another tree-living acrobat, the greater glider from Australia. It's the biggest of all the groups of gliding possums. It moves from tree to tree, rather like an American flying squirrel, but shares the koala's taste in food. This animal also only likes to eat eucalyptus leaves and blossoms. Look how it glides, almost like a paper airplane. It spreads out a membrane stretched between its front and back legs to form a gliding surface. This creature can actually glide for 100 yards, as long as a football field, before landing on a tree trunk. Then it just gallops upward again and launches itself onto the next tree.
Life in the trees is mainly a question of hands and feet. Keith is going to show you what I mean. Look at this eye. Here's that thin middle finger with a claw on the end. We've already seen how it's a perfect tool for getting grubs out of bamboo and coconuts. Now to look at the sloth again. The sloth's foot is bare underneath so that it can grip, but at the end there are 3 enormous claws, rather like walrus tusks.
There you are, Thane. 3 of them. But don't forget the two-toed sloth, which has got, would you believe, just 2 of them.
That's right. These animals all have feet that are designed to give a very good grip so that their hands are free for other things. Let's go to the dense forests of South America to have a look at some additional sets of well-adapted hands and feet.
Here's another sloth-like animal, the pygmy anteater of South America. It spends most of its time searching the tree bark for termite nests. It has big, powerful claws that tear the nests out. Then it uses its long tongue to pluck out the termites. That tail is bare underneath and ridged to give it a good grip. It hardly ever takes its tail off the branch, but always has it wound securely around part of the tree for safety. As you can see, it's walking on the knuckles of its front feet so that the long claws don't get in the way. These animals are almost as slow as sloths, but sloths don't have tails and they depend on their claws to come down trees. Well, it all goes to prove that there are many different ways of doing the same thing. This particular pygmy anteater has decided to leave its home in the trees, at least for the moment. But one thing's for certain, it'll be back soon.
Claws, feet, hands, or tails, whatever it takes to get along in the trees. This is a black-capped squirrel monkey. Squirrel monkeys get their names because of their relative size and the fact that they bound through the tops of trees. But they live in the South American rainforests in countries like Bolivia. You can probably hear his voice. You know, monkeys and apes are the loudest mammals in the world. Most mammals that live on the forest floor try to stay quiet to keep from being eaten. But they live in the tops of trees so they can make plenty of noise to communicate with each other. Squirrel monkeys, like many monkeys, live in large troops of 30 or 40 or more, all at once in a large family. Animals communicate in lots of different ways, but monkeys do it with different vocalizations or calls. Some mean stay away, some mean I'm in love. But another neat thing about monkeys is their eyes. Monkeys have binocular vision like people. They have their eyes on the front of their head so that they're able to see their food or the branches they're swinging toward. Like all monkeys, they have a good grip. You can probably see he has a grip somewhat like ours. Actually has thumbs for holding onto branches and also for grasping food. You see, they're omnivores, which means they eat both plants and animals. They'll eat leaves and fruits and seeds, but also little insects and things that they can catch in the tops of a tree. right? It's probably time for both of us to get back into the trees. We're back in the forests of Australia again, where the long-tailed pygmy possum is a real midget among tree dwellers. It's also a roly-poly butterball. Its front paws are like hands, which help it to climb, and the hind feet not only have thumb-like toes, but also inflated pads on the soles. And back to the ground, but only for a short time. Here's a tree animal caught at a disadvantage on the ground, so it pretends to be a leaf moving in the wind. It's a chameleon. Up in the tree, it looks even more like a leaf, as that locust might have been able to tell you. The flick of the tongue is so fast it's almost impossible to follow. It's literally quicker than the eye. Let's see it in slow motion now. That 6-inch long tongue shoots out to catch the locust in 1/4 of a second. Look at the turret eyes, each one swiveling to look in a different direction. That's why the chameleon's so good at catching its prey. Now that chameleon's tongue is so fast that you can't understand the mechanics of it, even in slow motion. But Keith is going to try to explain it to us.
Try, it's very, very quick. Look, I've got a rough chameleon drawn up here. And imagine you could see inside it. You'd see, if you could, a bone like this, like a wishbone, lying in the bottom of the mouth. And furled up on top of that is the whole tongue at rest, just like a concertina. Now, its eye, its swiveled eye, has focused on something pretty juicy here. It's seen, well, let's say a grasshopper. Sat there on a twig. So the next move is it opens its mouth like I've drawn it there and pushes the sticky pad right to the front of the mouth like that. Then suddenly a muscular contraction and out and back. I tell you another thing that helps it with this are the curious legs, the front feet of a chameleon. It's got 3 inside toes fused all together and 2 outside ones. So they grip very firmly and straight on the branch, just as if it's wearing mittens.
In effect, it's got 2 pairs of tongs to grip onto the branches. This keeps it steady when it aims for its prey. Now let's go back to the trees. Frogs live in trees too. There are several hundred species spread about in all the tropical rainforests of the world. If you look at this frog's toes, you can see that it's adapted for living in the trees. Big flat ends. They aren't suckers, but are covered with tiny hairs and a sticky substance that'll grip almost anything. During the day, in the heat, they sleep like this. When evening comes, they wake up and begin to hunt. Here's another tree frog. It's called a foam nesting tree frog for a very obvious reason. The name refers to those large nests of white foam hanging in the bushes. This foam is part of the breeding process. There's a little male on top of an enormous bloated female, absolutely full of eggs. The female produces the foam and discharges her eggs into it, and the male fertilizes the eggs as they emerge. It often takes all night to complete the nest. As the night continues, the nest grows increasingly large. Eventually, it may become as big as a soccer ball.
Sometimes other frog pairs join in until they produce an enormous cluster of eggs. In about 5 days, the eggs will develop into tadpoles and hatch out. Their wiggling will soften the foam, and the tadpoles will fall straight into the water below, where they'll eventually grow into frogs. Here's a bird-eating spider from the Amazon forest, only this time it's eating a moth instead of a bird. These spiders are as big as your hand, and they don't just build a web and wait for prey to come to them. They pounce on it. They're very agile as they move in the trees, partly because each of those 8 feet is equipped with a bright orange pad, covered with a thin layer of gripping hairs and a tiny claw. The spider is injecting venom into the moth through its fangs to paralyze it. Then it will inject digestive juices into the moth and suck the liquid contents out after it's pulled it into its lair. It's because of things like spiders and other predatory animals that caterpillars that live and feed among the leaves are so beautifully camouflaged. It's only later on, when they turn into butterflies, that they're allowed any extravagant colors. Sometimes even camouflage can't save a caterpillar. This one's being stalked by an equally well camouflaged praying mantis. What a skillful hunter that was. Now here's another mantis peacefully laying eggs, a different species of mantis. She's laying eggs in a foaming capsule, rather like those tree frogs. They're all masters of camouflage. Here's one that looks like a flower, for example. Which is the stick and which is the stick insect? It's not only a color match, but a match of perfect form as well. Even the movement could be mistaken for a twig blowing in the wind. Only the eye gives the game away. Male stick insects have got wings. They need them to find the females. But even these are camouflaged to look like brown leaves. There are hordes of insects of every color, size, and shape, each living in the trees in its own ingenious way. What follows is certainly a tale of great ingenuity and deceit. This European wood wasp is drilling a hole through the bark of this pine tree into a cavity inside. If we look inside, we can see the egg-producing tube, or ovipositor, entering the cavity. The drill works in 3 parts, which rub against each other. Once the hole is deep enough, the wood wasp passes eggs down the ovipositor into the cavity. When this process is complete, she withdraws the ovipositor and leaves the egg safe and deep within the cavity. Here they will eventually hatch into fat grubs. These then begin to eat their own tunnels throughout the woodwork before they become pupas. But even 2 inches below the surface, the wood wasp isn't safe. This is a female ichneumon fly, and she's bad news for the wood wasp. She feels with her antenna and manages to locate the position of the pupa below her with uncanny accuracy. Then she too begins to drill. Her ovipositor is covered by a protective sheath which is only withdrawn when the ovipositor is deep inside the wood. The ichneumon then stings the pupa to paralyze it. She passes an egg down her ovipositor and deposits it on the body of the wood wasp with deadly accuracy. When the ichneumon fly egg hatches, the larvae will have fresh wood wasps to feed on. Just another of the extraordinary things that can be found in forests all over the world. Remember the sloth hanging upside down and moving so slowly? And the amazing chameleon with its lightning-fast tongue, lining up on its prey with independently swiveling eyes. And the dramatic black and white colobus monkey, vaulting its way through the forests of East Africa, controlling those 40-foot leaps with its parachute fur and those long balancing tails. And of course, the foam-nesting frog, painstakingly creating its foamy nest so that its eggs will be protected until they hatch into tadpoles, a most unexpected use of a tree.
Around the world, forests are being cut down to serve the needs of human industry. But if we were to lose all the trees, we would also lose all the amazing assortment of animals that have adapted to life in them. It's important to all of us to balance the needs of people with the needs of these rare and wonderful animals. Join us again next time for another look at Animals in Action. A Canadian beaver dams a river and makes a freshwater pond for its family. And here's another freshwater species, trout laying eggs in a chalk stream. A water spider builds a bubble chamber below the surface of a pond. And far down the food chain, hundreds of microscopic animals live out their amazing lives in one of nature's most specialized life zones, fresh water. Hello, I'm Thane Maynard, and welcome to Animals in Action. If you're like most people, you probably think freshwater like this is a pretty common thing. But surprisingly, you're wrong. There's a lot of water in this world, but almost all of it is salt water. Only 1 part in 5,000 of the world's water is fresh water. It's a highly specialized environment, and I'll be investigating it along with Keith Shackleton.
Hello.
Keith, it looks like you've already begun something for us.
Yeah, well, I've drawn a river here, Thane, because we're going to talk about beavers. And we all know that beavers dam rivers. They build a dam across like that. And what happens? A pool is formed above. Now, let's have a look at the dam. Here's the dam. Easy enough to draw a dam. It's just a mass of sticks coming up from the bottom like that. But the level of the river below is quite low, and above, it's really quite high, nearly up to the top of the dam. Here's the bottom of the river going along. Then the beaver begins another great big piece of house building. The lodge starts from the bottom and it goes up and up and up, more and more sticks, till it comes up above the surface to form a nice, warm, snug platform. Then it still goes on building because it's got to make a roof. That's the living chamber in there.
And these are loose up here to allow ventilation.
Oh, sure thing. I mean, this is, yeah, that's where all the air comes into them. But the important thing is that this goes back down to the bottom, leaving these holes, because the thing is that the beavers have an underwater entrance all around. They can come and go as they please.
What makes beavers particularly important is that they're not only one of the largest freshwater animals, they're one of the great creators of freshwater environments for others.
And here's the real McCoy now, deep in the forests of Manitoba. This is a full-grown male. He's chewing away on willow leaves. Willow and aspen are riverbank trees and are what beavers like the most, grazing away with his huge chisel-like front teeth. These teeth are growing all through his life, and they're kept worn down by this sort of feeding and by felling trees to make his dam. The front feet have strong, sharp claws for digging and manipulating timber. And here's the dam it's built. The dam keeps back the water and forms a deep pool, just perfect for the beaver to build its lodge. The beaver has a thick, waterproof coat to protect it against the cold and can spend 15 minutes underwater by closing its nostrils and ears. The beaver has to dive to enter its lodge because the entrance is underwater. The lodge itself is built of sticks, timber, stones, and mud, well insulated for the winter, and with ventilation shafts and air conditioning. Beavers pair for life, and a family group of 12 or so will stay together, feeding on their winter food store of branches. The youngsters, called kits, spend up to 2 years learning their architectural skills from their parents. But when it comes to swimming, they must learn that early and well. Swimming, after all, is the most important part in the life of any water animal, and beavers do it extremely well. And here's another important freshwater animal, the otter. This is probably one of the most graceful of all river animals. It's completely at home in the water. It uses its web paws when swimming on the surface. It can swim below the surface for nearly 1/4 of a mile before coming up for air. This one's managed to catch an eel. It also searches beneath mud and stones for fish or crabs. It usually only feeds at night. Closer to civilization, here's an old mill pond. And while we're no longer in the wilderness, the world below the calm green surface is just as busy and wild as the world of the beaver and otter. These are Daphnia, often called water fleas because of their jerky motion. But they're not related to fleas at all. In fact, they're crustaceans related to crabs and lobsters. One pair of antennae is used for swimming, the other to feel their way around. The whole body is transparent. You can see the heart beating and the long green digestive system, green because of all the algae it's eaten. All those beating limbs covered in bristles are straining food particles out of the water and passing them onto the mouth. The greenish blobs you can see are baby Daphnia developing in the brood pouch. In a few days, they'll break out and soon become adults themselves. If you look closely at this piece of pondweed, you might detect something moving among the leaves. It's a hydra. It's related to jellyfish and anemones, so it's a very simple animal. Really just a long tube with a mouth surrounded by tentacles. It often contracts into a blob when disturbed. Hydras can reproduce themselves by budding, just like a plant. Even though each of these young hydras is still attached to the adult stem, it feeds for itself. Eventually, it will drop off the adult and start a new life on its own. But young hydras don't always begin as offshoots from their parents. There's an alternative method of reproduction used when times are hard, and that's simply an egg. There's the egg on the stalk of the parent. The tentacles around the mouth aren't as simple as they look. They're covered with rows of stinging cells called nematocysts. The hydra's body can stretch like a balloon when it swallows large prey.
Let's look at those nematocysts, the stinging cells, more closely, because they're quite interesting. Look at this one. Think of it as the finger of a glove that's inside out. Suddenly, the finger shoots out to form a sticky tube, and the hydra uses them to cling to plants as it moves about. Now here's another kind. Imagine that you've got a little Daphnia swimming by.
Okay, Thane, here's your little Daphne swimming by. A little water flea. There he is.
The hydra will shoot out its tube and wrap it around the victim, just like a lasso. Now this weapon's the most deadly of all. It's a real harpoon. The tube is covered in barbs, which inject paralyzing substances into the prey. Once it's used this weapon, the hydra has to grow a new one again.
Now this really does look like a strange animal, and it's got a strange name, Vorticella. With the naked eye, it looks like a layer of mold, but under the microscope, it reveals all its delicacy. It's a group of animals, really, each attached to the central stem. Each individual looks like an upturned bell, and each bell is surrounded by a mass of tiny hairs called cilia, which fan food into the mouth. This is one of the moss animals. Like Vorticella, each individual is part of a colony, and it feeds in the same way, using tentacles and cilia to waft food particles into the mouth. When you see the whole colony, you can understand why it's called a moss animal. Those little black spots are eggs. Hardly bigger than a pinhead, this rotifer looks something like an electric razor. Again, it's those tiny hairs, the cilia, going round which make it look like a rotating wheel. The cilia create currents to draw food into the mouth. Rotifers are soft animals, so they build a protective tube for themselves which they live in. It's beautifully fashioned like a honeycomb. The rotifer has a special brick-making organ behind its mouth, and it manufactures its own bricks of identical size and shape and glues them together to build its tube. This is the only spider you'll find living underwater. Not surprisingly, it's called a water spider. All spiders have to breathe air, so how can it live underwater? This particular spider solves that problem by building itself a bubble chamber of air. It weaves a platform of silk underwater and then goes up to the surface to collect air. It turns around and sticks its abdomen out into the air. When it swims underwater, the fine hairs on its abdomen trap the air in a silvery coat. Then it rubs the air off beneath the platform. The more air it puts in, the more the silk platform rises to make a dome shape. So what it's done is to make itself a diving bell, which it can visit whenever it needs air. The most extraordinary thing now occurs. Waste products from the bell diffuse out into the water, and oxygen from the water diffuses inwards, so the bell becomes self-replenishing. The spider has noticed the vibrations on the surface of the water, and it goes up to investigate. It's a fly drowning in the water. One quick pounce, and she has it. She takes the fly down with her to consume it in her underwater bell. She can't eat food unless she's in the air. She'll store any food she doesn't want in her diving bell. Sometimes she lurks inside the bell, waiting for prey to come near. Here's another animal which you may be more used to seeing on land. These are pinhead-sized baby snails developing inside an egg cluster. In another part of the pond, an adult snail slides over the vegetation. A snail really has just one big foot to move around on. The sole of the foot has waves of muscular contractions moving along its length, and this way of moving is so efficient that it can slide across weed, glass, even over the surface film of the water. You can see the snail's mouth and the toothed tongue which rasps away at the vegetation like a coarse file.
Thane, I learnt an interesting thing the other day about snails. Do you know that there are left-handed snails and right-handed snails, just as there are left-handed and right-handed people?
No kidding.
It's a fact, and this is how you tell them. You sit your snail down on the ground like that, with its opening facing you and its little spiral sticking upwards. Now, if that opening is on the right-hand side of the axis, facing to the right, you've got yourself a right-handed or dextral spiral snail. Okay, well, if you happen to find a snail that's this way around, with the opening there, like this, it'll peak upwards and everything, but the opening is facing the other way, to the left, you've got yourself a very interesting snail indeed, because that is a sinistral spiral snail, and sinistral spiral snails are very rare indeed.
How can a snail be left-handed when it doesn't have any hands? Well, it's something to think about.
This strange-looking animal is actually the larval stage of the all-too-familiar mosquito. You'll find it in any fresh water that's been standing around for a while. Hundreds hang suspended from the water's surface, breathing air through a tube at the back like a snorkel. And at the front, you can see bristles around the mouth, creating a current and drawing food particles straight into the mouth. The larvae will live this way for about 3 weeks until they're ready to hatch into the flying insect. The mosquito's so light, with its legs so well spread, that it can stand on the surface of the water. Looking at this creature, it's hard to believe that it's going to become one of the most beautiful and delicate of all pondside insects, a dragonfly. At this stage, it's ugly and aggressive. It preys on tadpoles or small fish. It remains in this state for about 2 years. Then, towards the end, 2 wing buds appear along the back. Finally, one night, the nymph climbs up a plant stem and suddenly seems to split down the back. From this split, the head, thorax, and legs of an adult dragonfly slowly emerge. Then the rest of the abdomen is pulled free. white threads are broken breathing tubes, which it only needs underwater. The wings take an hour or so to inflate completely as blood is pumped into them. Finally, a complete dragonfly with shining wings is sitting on its discarded nymphal skin. Soon it will fly off in search of food and a mate. If the development of an insect is complicated, the development of a fish from egg to adult is even more so. This pair of trout have swum upstream to lay their eggs in October. That's the female, and there's the male with the big hooked jaw. She's going to flick out a little depression in the gravel with her tail. Here she goes, laying her eggs. Then the male will move in and fertilize them. And there are the eggs, hidden among the gravel, but still well oxygenated by the current. You can see the eyes of a tiny trout beginning to develop inside after a couple of months. When the little fish emerges, it still has a large yolk sac attached to its belly. The yolk will last it a month. This means that the young trout can stay hidden among the gravel and doesn't have to hunt around outside for food, where it might get eaten itself. Gradually, the sac will be absorbed into the body and disappear. At the moment, the trout is still transparent, and you can see the heart beating and the gills. In fact, the gills are still underdeveloped and can't supply oxygen yet. So most of the oxygen is obtained through the skin or through the red blood capillaries in the yolk sac. After a month, the young trout begins to form dark bands along its body. Now it's feeding on caddisfly larvae and worms. This is the time when the trout are most in danger from predators such as kingfishers. In 2 or 3 years, the trout will be fully mature and measure about 16 inches in length. Not quite so lovely, perhaps, but another fish in the same stream. A feisty little guy which will eat trout eggs if he gets the chance. It's a bullhead, and it too has a highly specialized breeding cycle. That's the male, and he's carefully preparing a crevice for the eggs, removing all the stones and debris in his mouth. There's a female watching all this activity. To attract her into his cave, the male turns a dark shade and barks at her. And when she approaches, he grabs her and pulls her into the cave after him. It's real caveman stuff. And now, when he's got her trapped inside, she begins to lay eggs, a whole sticky cluster of them attached to the ceiling. He then fertilizes them and drives her out. But it's not as one-sided as it looks, because he stays there fanning those eggs for 2 to 3 weeks until they hatch, giving them all the oxygen they need. Overhead on the surface, there's another predator that well might attack the bullhead if it got a chance. It's a water shrew, one of the best swimmers on the river, and a deadly hunter. It's also the owner of one of the most voracious appetites in the animal kingdom. Right now it's found a worm, but it will eat almost anything it can catch. By the end of the day, it will consume more than its own body weight in its constant effort to maintain its prodigiously high metabolism. Quick, agile, and above all adaptable, the water shrew typifies the wealth of animals that have found a home in and around fresh water.
It's an astonishing cast of characters that live in this special freshwater world, from the beavers that control the flow of the water, to the fish that thrive in the river, to the mosquitoes and other insects that prey on microscopic life forms. It's just another example of the incredible variety of life that has found a way to survive on this earth, even in fresh water. I hope you'll join us again next time for another look at Animals in Action.
Some very tough animals have forsaken the lush green valleys to live high in the mountains, like these red deer of Scotland. Another tough customer, the brown bear of Alaska. A high-flying lammergeier, a special breed of vulture that haunts the Himalayas. And who would expect the fragile monarch butterfly in this gallery of tough mountain animals? Yet it, too, has a special mountain story to tell.
Hello, I'm Thane Maynard, and welcome to Animals in Action. Today we're going to be looking at the animals that live high on the mountainside and see how this specialized crew, from brown bears to butterflies, manages with the special problems of mountain life. Keith, can you show us in simple terms the different life zones involved?
Well, I'll try. Let's have a look at this. Here we got a mountain. Any old mountain. It could be the Alps, Rockies, Himalayas, Andes, whatever you like. Doesn't matter how high it is either. They're all the same in principle. Now, down at the bottom here, you've got lowland, foothill, forest, dense woods, deciduous trees, bushy-top trees, trees that shed their leaves. Here and there you get a fir tree, but this is the most common one. And in this area, no end of different sorts of animals. Now, if you go above that, you find that it's colder and harsher, and the trees are all conifers. They're larches, spruces, firs. And up they go, and there are fewer animals, of course, here too. Until you reach the top of this zone, and you come to the tree line. And that's where the trees stop. Now, after that, things get pretty rough. Very short, hardy vegetation, very little of it, mosses, rock, and finally, snowfields. And up there is the alpine zone. And the alpine zone, animals that have to live there know all about it, and they have to be very, very hardy indeed.
If you've ever been in the mountains, you've probably noticed how sharply defined the difference is between where the trees grow and where the alpine zone begins. It's a very abrupt, usually almost straight line, the tree line. Lots of trees below the line and no trees at all above it. Let's take a look at the real thing.
These are the Rockies, and up at this level it's too cold and dead for any life to exist. Just below, in the alpine zone, life begins. These tiny little inch-high plants are actually trees called dwarf willow. It's a very short summer at this altitude, so all the plants take advantage of the warm sun, filling the alpine meadows with color. This is the only time that insects can pollinate the flowers and mate themselves before the cold winds draw in. The higher you go, the colder it gets, and the vegetation gets thinner and thinner. Mosses and lichens give way to bare rock and snow. A high mountain, even in the tropics, can be covered in snow at its summit, with temperatures similar to those in the Arctic. And yet, just above the tree line, there are big mammals which somehow manage to scrape a living. These are Dall sheep from Alaska, cousins of the bighorns of the Rocky Mountains. The rams' crowning glory are their massive curved horns, which they use as battering rams in autumnal mating battles. The females have smaller, straight horns. These sheep are well insulated against the cold by their thick, woolly coats. But agility is the watchword of the Rocky Mountain goats. They aren't really goats at all, but belong instead to the antelope family. The agile youngsters can jump within half an hour of birth.
Ask any mountaineer and he'll tell you that his most important piece of equipment is his boots. And the same is true for the Dall sheep and mountain goats. Keith, I wonder if you could draw us a picture that would show these special adaptations.
Yeah, I'll do that thing. It's a foot that's not all that unlike a lowland sheep's foot, but there are differences. But the important thing, of course, like the mountaineer's boots, the very end, this cloven hoof. And that's in contact with the rock. Now, when the weight of the animal's on that, it spreads apart here so that that cutting edge can grip the roughness of the rock to either side. It also lets the pad come down, and that gives it an added non-slip surface to go against the rock. And the Dall sheep's got something else. In the heel there's a little scent gland, and that'll enable all the flock of Dall sheep to follow one another even when the cloud's down on the mountain and visibility is absolutely nil. But the mountain goat, this one up here, has got a similar foot, but with yet another adaptation. Underneath the hoof there, to either side, is a little concave area so that it's got the pad, it's got the spreading cutting edge, and it's got suction as well. And that's why if you watch these mountain goats, you'll see them walking along the thin end of nothing, and they never stumble or slither, let alone fall off.
Both species find safety by going where no predator dares to follow.
This is a yak, probably the toughest animal ever bred in the mountains. They're very sure-footed too, and they're well adapted to the cold with their thick, shaggy coats. Wild yaks have been driven all the way up to the inaccessible areas above 20,000 feet by competition from the domestic yak. For the Sherpas of Nepal, the domestic yak is a beast of burden, providing wool for cloaks and tents and milk for butter as a bonus. But gradually, this domestic breed may lead to the end of the true wild yaks of Tibet. The Nepalese Sherpas are not the only mountain people to rely on a particular animal for their livelihood. The South American Indians of the Andes have domesticated llamas for the last few thousand years. A llama is much like a small camel, but without a hump. Llamas are beautifully fitted for life at these heights. In addition to their thick coats, they also have more red blood cells than other mammals, enabling them to absorb oxygen more effectively from the thin atmosphere. A red deer stag roars across the Scottish Highlands. Red deer have developed one of the most distinct lifestyles of any mountain animal. During the winter, the males live separately from the females, searching the hillsides for heather and grass. At the end of winter, they begin to lose their magnificent spread of antlers, and you will see the stags standing on their hind legs and sparring with their front feet, as they begin to establish their pecking order within the group. As the spring grass appears, the stags disperse to feed. In June, the females have followed the flush of new grass onto the hills, and they give birth to their fawns well away from the main group. This fawn will have been the result of last October's mating season, known as the rut. At first, the fawn is helpless, but within a few minutes it will manage to get onto unsteady feet and feed from its mother. It will double its weight in the first 2 weeks. During this time, it will remain hidden in the long grass until it's old enough to join the rest of the herd. As summer progresses, the stags wallow in the peat bogs and rake the grass with their antlers in preparation for the autumn rut, when they will round up their females. Already the mountainsides are echoing with the roars of the stags. They begin to round up their harem. They proclaim their dominance by roaring. Only 2 equally matched stags will resort to fighting with locked antlers. The rutting season continues through the autumn, day and night.
That stag would be about 5 years old, but the antlers of a first-year stag are quite different. Keith, can you tell us a little bit about antlers?
Yeah, let's start playing at the beginning. Now, in Scotland, which is the traditional home of red deer, a first-year stag would be called a wee knobber, and it has just one point like that, one tine. Now, the second-year one is a pricket, and it's got a tine like that, and it could have just 2 or it could have 3, like that. When it's about 6, if all goes well, it's developed quite a different structure altogether. That's a tine sticking forward, a brow tine. That's where it joins onto the skull. Then it's got one here and one here. And at the end, a fork of 2 and another one behind, making 6 in all, 12 altogether on both sides. And that's a royal stag in its prime of life.
This is the point where they'll drop off each winter and start to grow back in the spring. As Keith has shown, the number of points provide a visual clue to the age of a particular deer and therefore indicates its relative dominance in the herd. Antlers are quite literally status symbols, and very important ones in red deer society. We're 18,000 feet up now in the Simien Mountains of Ethiopia. This is the home of the gelada baboons. They're also called bleeding heart monkeys because of the vivid red chest patch. These gelada baboons are restricted to these mountains. When you think about it, monkeys should make quite good rock climbers with their 2-legged stance and grasping hands and feet. The troop has come up from the cold valleys below where they spent the night to feed on the sunlit plateaus above. The food is so poor that they have to spend most of the day grubbing about searching for leaves, roots, and grasses. It's essential for the troop to keep together as a protection against enemies such as leopards. The troop tends to fall into 2 groups, young males without females and big males with their harems of females. When night comes, the troop begins to move down towards the escarpment edge. The rear is brought up by the senior dominant males. In this way, the females and young are protected on all sides. Finally, the troop disappears into the valley, where the baboons will sleep on rocky ledges, well out of the reach of predators. Sometimes the inaccessibility of the mountains provides a safeguard for the animals living there. This has happened in Zaire, where spreading agriculture has gradually encroached on the forest homes of a rare and impressive animal, the mountain gorilla. The mountain peaks, Kahuzi and Biega in Zaire, are one of the places where this shy animal is to be found. The summit is bare volcanic rock, but the lower slopes are heavily forested above the 6,000-foot level. This lush rainforest is the ideal habitat for the mountain gorilla.
The forest contains about 250 gorillas. They travel in small family groups. Each are led by a large silverback male. A gorilla family spends most of the day feeding. An adult male gorilla consumes about 60 pounds of vegetable matter in a day. That's equal to about 80 boxes of cornflakes. The silverback male may make noisy charges as a warning to defend his family. But contrary to common belief, if left alone, gorillas are really very shy and peaceable creatures. At midday, they often rest from their non-stop search for food, and they get all the water they need from the leaves they eat. Only because of the difficult nature of the terrain was this precious forest left untouched by farmers. Bears weren't always mountain animals. They have been driven up into remote and inaccessible mountains by man. They survive because they adapt. Summer is when brown bears fatten up to bursting point in preparation for their winter hibernation in a snug den. By living off their fat in the winter, they don't have to spend energy foraging in the snow when there's no food around. The litter of 2 cubs is born during the worst part of the winter. This adult seems to have a pair of cubs from another litter mixed up with her 2. How can a creature of such enormous bulk as a brown bear manage to find enough food even in summer to survive in the mountains? The answer lies mainly in its behavior. When the salmon are running in the ice-cold mountain streams, the bears have a field day, wading out into the shallows and flipping the fish out of the water with their front paws. The exhausted salmon are easy to catch in the shallows. They are a delicious and highly nutritious delicacy. Bears don't only catch salmon, of course. They will eat just about anything. Honey, grubs, roots, waterweed, berries, fruit, and live prey. This is the secret of their success. This is a pika. It's a bit like a guinea pig, but its nearest relative is a rabbit. There are pikas in North America, in Asia, and there's even a species that lives on the slopes of Mount Everest, right up to the 18,000-foot mark. It's got bristly hairs on the soles of its feet, and that gives it a firm grip on the rocks. But the most important thing about the pika is the fact that it has found a way to stay at this high level throughout the year, simply by laying in a huge pile of dried vegetation during the summer. Oh boy, I know how he feels. The alpine marmot is a very regular little animal. After it wakes up, it leaves its burrow to sun itself on the rocks. Then it feeds for a couple of hours, then more sunbathing. Marmots are happiest living high up around the tree line on boulder-strewn slopes. Unlike the pika, marmots move lower down the mountains when winter comes. This is mainly because they don't build themselves a food store like the pika. They live in communities among the rocks. Marmots are always on the alert. They stand upright and survey the mountainside for predators, eagles or foxes mainly.
Now this little animal, the chinchilla, comes from the Andes Mountains in Chile. It's famous for the most luxurious fur in the world, and it needs as much warmth as it can get up in the mountains. It has a number of other adaptations which also help it to survive in the cold conditions. For instance, it carries its young for 10 days longer than the lowland chinchilla, so that when they're born, they'll already be covered with fur and able to protect themselves against the cold. It's also been noticed that the mountain race has shorter ears and tails than the lowland race, because this prevents it from losing too much heat from the extremities. But of course, the adaptation that chinchilla is most famous for is its soft coat of fur. It insulates it against the cold. At one point, there was such a demand for coats made out of chinchilla fur that the animal was threatened with extinction. But luckily, the fur coats got too expensive and people stopped buying them.
The weather in the mountains is extreme, causing swift changes of air pressure and temperature. For the hunters of the mountains, it's best to be airborne, looking down on the peaks instead of looking up at them into the sun. This is, of course, the domain of the birds of prey. Sweeping upwards, climbing without a single flap of wings, the lammergeier soars on a thermal against the backdrop of the Himalayas. Like other mountain birds, the lammergeier must contend with the very thin air of high altitudes, which provides less lift. It requires the ultimate in flying skill.
And before we go any further, I think we owe you a description of just what thermals are that these high-flying birds glide on. Keith?
Right, thermals. Think of a thermal as an enormous but quite invisible hot air balloon rising into the sky. Here you've got the ground being heated by the sun. The air above it gets very hot and suddenly breaks away and it begins to rise. Cold air comes in like that and takes its place. Now, a bird, if it stays on top of that rising air, can go round and round circling without a beat of its wing. Think of another situation. Here you've got a ridge, a mountain like that, the wind blowing up it. It's diverted upwards so that it's vertical lift here, and a bird, a vulture, an eagle, can sit up there forever, going back and forth just like a hang glider. And think how valuable that is to these big mountain birds. They can see everything that moves down there on the valley floor and use up no energy at all.
Thanks, Keith. The lammergeier we saw earlier was a vulture, so it was looking for carrion. But the golden eagle, which also uses thermals, is a true hunter. The golden eagle is a very widespread species. It lives throughout the northern hemisphere, in the mountains of Europe, Asia, and North America. It's the perfect hunter, with a powerful hooked beak to tear flesh and forward-facing eyes with acute vision. It also has strong talon claws to strike its prey. Eagles are probably so successful because they will eat practically anything: mammals, birds, even carrion. Here it's after a hare. If you look very carefully, you'll see there's a bird crouching beneath the rock. The ptarmigan is a master of camouflage. It has developed plumage which changes to match the seasons. In autumn, it's halfway through a molt from brown to white. When the first snows arrive, the ptarmigan has become pure white to match. The only giveaway to its presence are the black eyes and bill. Even a chilly mountain stream is home for one bird. This is an American dipper, and it can actually fly underwater. It seems to be dipping below the water all the time. Its bobbing motion on rocks is believed to be a form of camouflage against the background of moving water. There are no insects around in the cold air, but the stream is full of developing insect larvae, and that's the dipper's secret. It never leaves the stream. Here's a European dipper with its white front. All dippers swim below the water like this. It's really very close to flying, as dippers actually use their wings underwater. It quickly scans the river bottom before diving in. It's extraordinary that it swims so well without webbed feet. Its heart rate and consumption of oxygen decrease when it dives, allowing it to stay below for up to 20 seconds. A thin membrane closes over its eyes, allowing it to see clearly underwater. The feathers trap air, and in order to survive the cold, the dipper is beautifully padded out with a thick undercoat of down.
The feathers are well waterproof so that they stay dry. The only real mountain duck is the aptly named torrent duck. This brilliantly colored bird haunts these thundering white waters of the high Andes. It's beautifully streamlined and belongs to a group of ducks called stiff-tails because their powerful tail acts like a rudder in the water to steer it through the strong current. Most water birds would be swept away in these conditions, but the torrent duck is built to take it. Some animals need the mountains only for one vital stage in their life cycle. The monarch butterfly is one. The story begins in California, where the monarch caterpillars feed on milkweed, so called because the plant exudes a white liquid when cut. It's poisonous to many other animals, but is the sole source of food for the monarchs. When the caterpillars are ready to pupate, they hang up in the leaves and molt off their last caterpillar skin. This takes about a minute and a half. The pupa is soft at first, and it wriggles around so that it'll harden into just the right shape. Then the pupa establishes a good grip on the plant. It takes about 2 weeks for the adult butterfly to develop inside the pupal case. When the pupa is ready to molt into the adult, it splits down the middle, and the beautiful adult butterfly emerges. The body fluids pump out the wings. As soon as it's an adult insect, it'll be ready to mate and produce further generations. The cycle repeats itself until the last generation of the summer, where most of its adults are infertile. This is where the mountain story really starts, for these butterflies migrate right down to the heart of Mexico, toward the Sierra Madre Mountains. They pause by mountain streams to drink. They are all headed toward the Oyamel spruce forest above 10,000 feet. Then suddenly, every tree is covered with thousands of butterflies. They need the cold temperatures at this altitude to allow them to roost in a state of suspended animation so that they use very little energy. Miraculously, the cold also triggers them into fertility, so that when they wake, they can mate immediately before starting on the long journey north. The monarch butterfly, the brilliant but tiny sovereign of the mountains. And among his far-flung subjects, the little marmot grazing in the short grass of summer. And the incredible Dall sheep casually leaping from crag to crag across the chasms. From butterflies to brown bears, it's a remarkable set of animals adapting to an equally remarkable habitat. Mountains can be cold and dangerous, and there's almost always a shortage of food. But no matter how difficult life may be up there, certain animals will always find a way to survive the challenge. Thanks for being with us, and join us again next time for another look at Animals in Action.